So now that we've learned about our 6 VSEPR shapes, we can go back to our practice packet and look at our Lewis dot structures, count up how many bonding regions are on my central atom and how many lone pairs are on my central atom, and then identify or name what the VSEPR shape is. So you may want to have out your notes handout listing the 6 different VSEPR shapes. That way you can visually see those number combinations that will give you whatever the shape name is. Okay. So this is fun because it kind of goes, I feel like, it does go much faster than drawing a Lewis dot structure, especially when you start to get familiar with knowing these shapes. You'll kind of be able to pick it out a lot easier. Okay, so we're starting off with our water molecule here. So number of bond regions, meaning how many bonds are coming off of that central atom of oxygen. Y'all, there are 2, right? How many lone pairs on that central atom of oxygen? 1 pair, 2 pairs. He's got 2, 2. If you'll remember, if I add 2 plus 2, that gives me my 4. That's my tetrahedral kind of grouping category, except instead of having all 4 things be bonds, 2 of them are in lone pairs. So if I check my chart, my 2-2 combo, that gives me a bent shape. So we would call this bent. Nice, that was not too terrible. I'm going to come back to this one. I want us to kind of chew through a little bit more of these. Okay, let's do my CH4. I've got 1, 2, 3, 4 bonding regions coming off of the central atom and no lone pairs on the central atom. 4 things and no lone pairs, meaning all 4 of them are in bonds. That is my true tetrahedral. There is not enough space in this little box to write tetrahedral. So whatever way you need to, hedral. That sounds good. Next up, I see three things connected to the central atom. My brain is already thinking trigonal. Let's see if it works out. Yeah, I got 3 bonding regions, and he has got a lone pair, 1 lone pair on the central atom, right? When you see a 3 on your bond regions, you think trigonal. In fact, I can already write trigonal. But I got 2 options. Are we trigonal boring and plain? Are we trigonal pyramidal with a fun little party hat of an lone pairs of electrons? Let's see. We are trigonal pyramidal. I love that. Pyramidal. Awesome. Okay. Let's do this one down here, and then we're going to bounce back up and tackle that chlorine. I have not forgotten about him. Well, that is a possibility for me to forget about him, but I will not do that for us today. Okay, y'all like, oh no, this is a resonant structure. Which one do I do? It does not matter. Pick one. They will all be the same shape. Let's pick this original first one that we drew. He has got 3 bonding regions. Keep in mind, I do not care what type of bond you are, whether it be single, double, or triple. It counts as 1 bonding region if it is all going to the same thing, which it is in this case. Okay, so I've got 1, 2, 3 bonding regions, lone pairs. And when I say lone pairs, I mean lone pairs on the central atom, I know there are lots of dots on those oxygens, but those are not the central atom. My central atom is sulfur. He has no lone pairs. I love the dynamic of these 2. Trigonal pyramidal with his fun little party hat. Oh, that 0 is so boring. That must be my trigonal planar shape. So he will be flat. So this is trigonal planar. Okay. I still feel like I'm trying to forget about. No, I'll tackle. We'll do him now. I'm not putting him off because he's hard. I'm just putting him off because I wanted to chew through some of these normal ones first. Okay. This is tricky because if you only have 2 atoms, there's no central atom. So I don't have anything to write in here because these only apply to stuff coming off of the central atom. Then you're like, well, how the heck am I supposed to name a VSEPR shape? I'm going to show you this. Yes, I got 2 things. Well, let's make them the two of the same atom. There we go. So now I have the 2 of the same atom here. I don't know about y'all, but that looks like a straight line to me. The shortest distance between 2 points or 2 atoms is going to be a straight line. So if you only have 2 atoms in your molecule, it's going to be linear. And y'all are like, but the linear, yeah, that's a linear if you have a central atom. But if you only have 2 atoms in your molecule, it's going to be just linear. Not a big deal. Look at that. Amazing. Okay, let's do a few more. Which ones do I want to do? Let's do Let's do a few more. Okay, so I've got, on this one, I've got carbon is my central atom. He's got 4 bonding regions. No lone pairs on the central atom of carbon. 4 things, 0 lone pairs, tetrahedral. Sorry if I went a little fast. I'm assuming that eventually you'll start picking up on this, but you may not be quite as quick as I am after I've been doing this for a long time. Okay, my central atom on this one is carbon also, but he's got 2 bonding regions. And on carbon, no lone pairs. Whew. No lone pairs, making that bond want to kink or bent down. We are, yes, in fact, linear in shape. Here's another situation where I only have 2 atoms. Yes, they are different atoms, but there's only 2 of them, so I've got to be linear, which means I got nothing in here. Next one down, I have got arsenic tribromide, my central atom of arsenic. He has got 1, 2, 3 bonding regions. I'm thinking trigonal. Woo, trigonal something, trigonal something. Does he have a fancy party hat? Yes, he does. 1 lone pair means he is fun, he is fancy, he is trigonal pyramidal. This one was a little bit of a fun one for us to draw our Lewis dot structure for. It's also going to be kind of fun to identify what VSEPR shape he is. He's got 2 bonding regions, right? And on his central atom, he's got no lone pairs. 2 things and nothing causing them to kink down together. They will be 180 degrees apart. He will be linear in shape. All right, I think that is the, no, I'm gonna do one. I keep saying I'm gonna stop, but these are so fun. We did do this number 14 one where we showed resonance, okay? So on this one, I can pick either one of these structures. Both will show the same shape. Focusing on the top one, I have 2 bonding regions and 1 lone pair, right? 2 bonding regions and 1 lone pair will be bent. So one thing I like to think about with all of my VSEPR shapes that have 2 bonding regions, which 3 of them have 2 bonding regions. Okay, if I have only 2 things bonded to my central atom and no lone pairs, they're going to be linear. But if I have 1 or even 2 lone pairs, that will cause a bent shape. So I physically think about me putting my 2 hands as far apart as possible. And if there are no lone pairs in my center of my body, my bond angles will not squeeze together. But if there are lone pairs on my central atom, they will bend down in some way. So that's how I think about my molecules who have 2 outer atoms. It's all about the lone pairs. If you have lone pairs, you will become bent. Let's see. And I think that actually is all I want to do with this practice. I think it is really straightforward, especially if you use your VSEPR chart. This is super satisfying. Also thinking about it in the groupings of your family absolutely help out. No, you do not get this chart on your test or your quiz, but hopefully the visualizing the shape and thinking what it means if you have lone pairs and how that's going to affect your shape will come in handy.